Hello there. My name is Stephan Todd, and I would like to welcome you to our webinar today, which is entitled Workflow Automation Using Material Script. I'm the Senior Product Manager for Material Studio, and I've been involved with the development of Material Script right from its initial inception in Material Studio 4.1 all the way up, and I'm still actively involved in assigning Material Script and the functionality that gets exposed in Material Script up to now. Now, before I start, I would just like to ask everybody to mute their phones, please. You can do that using *6 to mute. If you have any questions, please type them into the question box, and I will answer them at the end. Okay. So what am I going to do today? Well, I'm going to give you a very brief introduction to Material Script. This will be just a few slides really on some of the advantages and disadvantages of Material Script and why you should use Material Script. I'm then going to talk a little bit about how you can develop scripts in Material Studio and the tools that we added to make script development more easy and show you how they work. I'm then going to give a very simple example of the Material Script API, and this will be based around the Properties Explorer to give you an idea of how we designed the scripting API and how you should think about using it in terms of making most efficient use of it. I'm then going to go into an application example, and this is a script that I posted on the forums some months ago now, which was looking at calculating surface tension from a mesoscale calculation. So using DPD in mesosite to run the dynamics, and then stretching the system and looking at the resulting stress. So I'll talk about that in quite a bit of detail. I'll give you an introduction to the area, why we were interested in it, and then talk about the workflow. And then finally, I'll wrap up with some resources that are available and also some future webinars that are coming up in future events. Okay, so why did we decide to enable Material Script in Material Studio? Well, basically, one of the things that we wanted to do really was to look at the enablement the enablement of repetitive tasks in Material Studio. So one thing that you may do, especially if you work with things like polymers, is you'll build an amorphous cell, and then you'll split that amorphous cell trajectory into unique XSDs, and then from those XSDs you will run some geometry optimization on each one. You may run a temperature cycle, and then run some dynamics, probably NPT to equilibrate the density, follow that up with some NDT dynamics, and finally calculate the property that you're interested in. And if you're just doing that for a simple solubility parameter, you're already stringing together 5 or 6 different calculations. Well, we thought wouldn't it be great if instead of having to go through the user interface to do all those calculations, you could just write a bit of script that would send off all the calculations consecutively for you and bring back the results, and you will be able to have some level of reporting on those results in terms of writing out to text documents or writing out to study tables. So the initial driver for this was really the automation of repetitive tasks. One of the things that it also gives you, however, is full access to the underlying Material Studio data model. And by this I mean everything that's available in the Properties Explorer. So at the moment, if I do a calculation of hydrogen bonds, for example, what I can do is I can just see those hydrogen bonds on the screen, and that's very useful. But what I might want to do is get a little bit more information about those hydrogen bonds. So I may want to calculate the mean length of the hydrogen bond and see how that differs from the min and max lengths of those hydrogen bonds. At the moment, through the user interface, this is a fairly laborious task. I'd have to click on each hydrogen bond, write down its number, its length, and then go through and do whatever I need to get those stats. Whereas with script, we can write a little bit of 4 or 5 lines of script that just goes through each hydrogen bond, gets its length, and pushes it out into a file, or I could push it out into something that calculated the statistics that I wanted. So giving access to that data model actually provides a lot more information about the system than you can get just through the user interface, or you can get with ease through the user interface. This also links into the capability to define custom analysis tasks. A lot of scripts that have been written and are available on our forums are related to things like, I want to understand more about what's in my system. I want to look at hydration bands around and clusters around a particular molecule type. All those sorts of things you can do very easily using Material Script. And in the end, what this does really is it extends the functionality that's available in Material Studio beyond what you can do simply with the already advanced user interface. The final thing that it enables you to do, and it's not something that I've seen yet really on the forums, but it's certainly something that I've experimented with, is you can run third-party applications. So you could use the Perl framework to launch your own applications and then pull the results back into Material Studio. Obviously, that's a fairly advanced way of using Material Script, but it is a possibility. So at the moment, well, I say we introduced Material Script a few years ago now, and what we started to do was really just expose some of the functionality in Material Studio. So initially, we exposed just a few of the bits of the materials visualizer, things like hydrogen bonds and close contacts. And then we've extended that over the years now so that we include nearly all of the functionality in the materials visualizer. There are still some exceptions, but nearly everything is exposed through Material Script. Also then in terms of the modules, we've exposed Foresight Plus, we've exposed amorphous cell, mesosite, so all of our classical simulations are good classical simulations modules. And then on top of that, we've exposed some of our quantum tools, so DMOL and CASTEP are exposed. And then finally, some of our crystallization and analytical tools, so polymorph predictor and the motif search, they're exposed. And also parts of Reflex are also exposed. So in general, what we do is, we look at modules and we respond to customer requests. So if you see a piece of functionality that isn't exposed through Material Script, and you can let me know, how you would think that would help your workflow, I'll be more than happy to listen, and then we can look at exposing these in future versions, as this is very much an ongoing process for us. Okay, so what do I do to develop a script? Well, first of all, I have to write a script. So we created a new Perl script document, a Material Script document, and you can see an example of this here. So what we have is a very simple document, and what we have is the availability to do simple things like syntax highlighting. So you can see that comments are in green, commands are in red, and then variables are in collections and variables are in grey. And you can customize all this to your heart's content as much as you like as well. We also have simple things like line numbering in the script editor. Bookmarks, very useful if you're generating very long scripts and you want to jump up and down between certain areas, and things like search text highlighting. And then also we have error reporting, and I'll come back to this later on, but basically you'll see if there's an error down here, reported down here. You can see it says new NW. Well, that should be new, and this links the error back into the script. So simply clicking down on the error itself will then take you to where the error is in the script. So although we didn't want to provide a massive scripting environment, that's not really our specialist area, and there are tools out there to do that. We did want the capability to provide you with everything that we thought the general scripter would need in terms of developing a script. So that's the document and the view that's associated with a script. Once I've developed a script, however, I want to be able to start to debug that script and to look at what I can do with it. So I'll nearly always make mistakes when I'm typing stuff into a script. So the first thing that I'll do is I'll do a syntax check. And a syntax check is a very simple check, and all it does is it goes through and checks whether the Perl syntax is okay. So if, for example, you've missed a semicolon off the end of a line, you'll get an error. Or if you have mistyped a command, you will get an error in some cases anyway, some of the Perl commands. And so all this does is this returns these things in this output tab, and you can have a look and see, and again it links back to those errors so you can look and see what's going on. However, that doesn't necessarily capture all errors that can happen in a script, partly because of the way Perl is. Perl has this identity that is called its weakly typed and it's late bound. So this doesn't really know, Perl doesn't know what a material script function is. And so until you actually try and run that script, you won't find if you've mistyped a material script function. So what we have instead, or alongside the check syntax tool, is we also have a debug tool. And this effectively runs the script locally on the client side without moving it over to the server. And this then enables you to find any extra errors that you may have introduced into your script. Generally what I would do is I generally always hit check syntax before I do anything with my script, because that's most likely to pick up any errors that I've created. I'll then go to debug and debug my script, and then when I'm ready to run it into production mode and test it properly, I will go on to the next one, which is to run the script on the server. So when I want to do this, I then have a very standard job control, that's something that will be familiar to all of you who have used Material Studio in the past. So what I can do here is I can specify my gateway location, and you can see here I have this just set to my computer. It will take up, it's integrated as with anything in Material Studio with queues and job descriptions, etc. And also you can see that I can run this in parallel. Now, if I do select to run in parallel, this will only run in parallel the modules that I have defined as being, the modules that support parallel execution. So if I check on run in parallel, it will run Foresight plus Dynamics and geometry optimization in parallel, and it will run DMOL or cast step in parallel as well. But this was something that was added in 5.0 to enable users to take advantage of scripting and their parallel architecture. One other thing that is interesting is how do I deal with multiple files, because in a Material Studio world, in a UI-based world, what I tend to do is point to some files and then hit run, and it knows that whatever file is in focus or whatever files I pointed to, that's what I want to run on, because I have a dialog. However, with Material Script, you no longer have a dialog, you have a document. And so what it does is basically it will transfer all the files that are in the current folder will be transferred automatically over to the server to run on. So it's important that if you want to run on multiple files, to have them all in the same subfolder or the same folder as your script for when you hit run on server. You could also transfer files over in subfolders if you wish to do so. To be honest, I've never really got to the complexity that I've needed to do that so far, but the functionality is there. And obviously another way of doing this is to put files into a study table. So you can put individual XSDs into a study table, or alternatively even into a collection document, and you can run, and those will be transferred over to the server, and then you can iterate through that collection document or study table. One other thing that I'd like to add in here, which I don't think people know about very much, is there is a piece of API called Update Views, and you can use Update Views to be the equivalent of a live update on the server side. So as you'll know, if you run a Material Studio calculation, you'll get certain things that are updated every minute or 10 minutes or whatever you specify. So you can do things like update the structure or the chart document. You can do the same thing with documents in script. So you can pick on specific documents, and if you have update views, these will then be returned to the server for you, periodically so you can see how your script is progressing. Okay, so that's really a little bit about how you would go about developing scripts and the tools that we provided to do that. So next I'd like to just look at a very simple example of the API. And this, for those people who don't know, the API stands for the Application Program Interface. And this is basically the API is the script that you write. So one thing that is one of the things that when we designed the API is to make it really as close to the user interface as possible, so that would then make things simple and very easy for people to kind of work through and understand. So this is an example that's based on the Properties Explorer, and what I want to do here is get the number of atoms of a specific molecule in a structure. So what I can do then is very simple. What I do here is I go and I look at the molecule filter. So if I have the molecule filter here, so this is molecules that I have here, and this relates back to the molecule filter that I have there in the Properties Explorer. So basically what I do is I take whatever the name of this filter is here in the Properties Explorer, and then I pluralize it, I add an S on the end, and that then gives me the API that I need to get into that filter. Once I've done that, I can then identify the molecule that I'm interested in by its name. So you can see here I have the name is polyethylene, and this backs back to the name down here that's in our Properties Explorer. And so already you can see that what you can do here is you can flip between the XSD and the script document, and you can very easily work out a way of generating the script API that you need. Once I've got that far, then the final thing that I want to do is I want to work out the number of atoms in the script, and this is again another property name. So once more what I can do here is I can go and click on, I go and type in num atoms, and this corresponds to the number of atoms property that you can see down here in the Property Explorer. So this is just one way of getting information, and again I might use this to get hydrogen bonds or close contacts or any of those other kind of properties that are stored in the Properties Explorer in Material Studio. But I hope to have shown you that this, there is a pretty simple relationship between what's shown in the Properties Explorer and what you would type in a script. Now I haven't got an example of this, but just to lead on from that, if I wanted to invoke a module, in Material Studio I would click on modules, and then let's say Foresight, I want to do a geometry optimization. I would do modules, Foresight. When the dialog comes up, I would select the task geometry optimization and hit run. And in a very similar way, if I want to do that through script, I would type modules, Foresight, geometry optimization, run. So a very similar approach from both the user interface and the scripting interface in all cases to try and make it as easy as possible to use. And we'll see some examples of that later on. Okay, so that kind of is a very brief overview of the Material Script API. I guess one thing that I did forget to mention, which I should mention right now, is that also the API is very heavily documented in the Material Studio online help. I'll come back to that at the end of in the resources section, but it's a really great place to go and find out what you can actually do with Material Script. Anyway, just to move on, one example of the Material Script, and this is an example that is in the Material Studio online help as a tutorial, and then I extended the tutorial to include some other work that was done on this same paper, where effectively they changed the lattice dimension to the structure to see how a membrane responded to it. So why was this interesting? Well, basically the area was looking at the effect of non-ionic surfactants on cell membranes, and so they already knew that if you add a disinfectant to a system, a cleaner, then this can cause cell damage and death in structures. There are several different places where the disinfectant can act, but the main, most common area is to act on the cell membrane. And the cell membrane consists of a variety of different things, of lipids and membrane proteins. So the question was, can non-ionic surfactants, which have typically been thought of as being fairly inactive against bacterial growth, but can they also cause or inhibit bacterial growth by causing rupture of the membranes? And what they wanted to do in this case, and this was some work done by de Groot and Rabone, and you can see the reference at the bottom of the slide here. But basically what they did was then they built several structures, and these structures were all using a DPD methodology, dissipated particle dynamics methodology. So what they did was they built structures with a lipid membrane, and then they introduced a surfactant into that structure, into that lipid membrane, and obviously they had water in there as well. And then they looked at the effect of adding the surfactant to the lipid membrane. And what they saw was that as you add more and more surfactant into the system, the membrane becomes weaker and weaker, and the cell membrane breaks down, which would map on with the results that they found, which was that the non-ionic surfactants do actually inhibit the bacterial growth by weakening the cell membranes. And this was an interesting area because to get to the kind of time and length scales that are required to do these sorts of calculations, you have to do something like a DPD type of calculation, a dissipated particle dynamics calculation. So I won't go into any real details of the actual calculation. That's available in the tutorial and available in the papers that they published. But I want to go into a little bit more detail on the workflow that we then used to perform this simulation. So effectively what we do is we start off by building some structures. And the initial thing that we did was we built mesomolecules, which were the simple individual molecules that were going to go into our structure. And then from that, we used the mesostructure builders to build larger periodic boxes, which contain both the cell membrane and our water, our solvent. And then we built several of these with different layers of, with an increasing concentration of the surfactant molecule in each case. Now currently this is not available through material script, so this is a manual task at the moment that you still have to do within Material Studio, but still an important part of the workflow. Once we've done that, you then have to set up the calculation. And because this is a DPD calculation, it's slightly different from a standard classical dynamics calculation. So here what we have to do is we have to design our force field or define what our force field is. And again, in this case, I use the user interface to do this. In theory, you could create the force field through material script, but that would be quite a large calculation to go. A large script to do. You may actually want to do something like create the force field initially through material script, and then have your material script tweak that force field and look at the effect on the parameters and on the system. That's equally possible to do. And again, applying force field types is something that I could have automated in this case, but again, because I'd already built my structures in Materials Visualizer, I used the user interface to do that. However, the part that gets more interesting is when we get onto running the dynamics. So what I'm going to do here is I'm going to define the dynamic settings, and then I'm going to perform an equilibration run. This is done because I'm starting from a pretty raw structure, so I want to run along dynamics to equilibrate the structure. Once I've done that, I then go into a loop. And in my loop, what I'm going to do is I'm going to copy the last frame out of the dynamics trajectory, and then going to stretch the cell parameters, the lattice parameters, and then perform a new molecular dynamics calculation, and then analyze that to get the property which I'm interested in, which is the stress in this case, and the stress components. And then this loop will go around and around, copying the last frame out, stretching the lattice, performing molecular dynamics, and doing the analysis until I get to a number of steps. And so this script is available already on our Accelerus forums. I don't expect you to write down that number, but you'll be able to, when I've sent the presentation later on, you'll be able to access that. So there are several parts, and again, the light blue areas are the bits that are covered in the script. But what I'm going to do is I'm going to talk just a little bit about the areas in bold. So I'm not going to go into stretching the lattice or performing a second dynamics run, because that's very similar to how we performed our first dynamics calculation. So I'll cover that beforehand. So first of all, what I do is very simply I build my structure. So as I mentioned earlier, I use the mesostructure tools to build my surfactant and lipid, and then, the mesomolecule tools to do that. And then I also build a water, and I build it into this system where you can see what I've got is a mixture of lipid and membrane, surfactant, membrane, and water. So what I have here is this area here. The blue is all my solvent molecule, and then this is my membrane here. And at the moment, this membrane is consisting of a combination of both surfactant and lipid molecules. But obviously, I built different ones looking at the different percentage of surfactant and lipid mixed in that membrane. Okay, so the next step is just to go through the calculation setup, and again, I'm not going to go into a lot of detail in this. The one important thing to remember here is that what I did was I took the results from the interaction parameters for the force field definition from the paper by de Groot and Rabone, and what I did then was I used the DPD force field dialog to create a force field that could be consumed by mesocyte. And mesocyte, as with foresight, requires a force field that's in physical units, so that conversion is handled automatically for me by mesocyte. So I used the UI to do this, but again, I could quite easily go in and manipulate that force field using material script to look at tuning parameters. And again, I also use the UI, so the two kind of buttons that I use here. First of all, I create my force field, so I use that button, but then the second button that I use is type, and that automatically types the structure. Again, I could have used a bit of material script to do that, and there is a simple example on the forums already of a material script where you can go through and type a mesoscale structure. So now onto the actual bulk part, and this is where I get to actually doing some scripting. So again, what I'm presenting here are fragments of the overall script that's available on the forums. I'm not going to go into all the details of it, and so some of this looks slightly different in terms of layout, but the ideas behind it are all the same. So the first thing that I want to do here is I want to load a force field into my document and into Material Studio on the server side. And so we have a very common way of doing this. We have this idea of $documents, and $documents can open up a structure or a study table or a force field or whatever. And so what I've done is I've given it a force field name and the extension, and it just loads up that force field. The next thing that I want to do is set some global settings for my calculation. So within Material Script, I can either choose to set settings globally, i.e. at the module level, or I can choose to set settings at the task level, i.e. locally. And what I do in most cases is I will use global settings to set things in dynamics, such as the time step, maybe the temperature, the force field that I'm going to use. So things that won't change when I go from a dynamics, an MPT to an MBT dynamics, or when I go from a geometry optimization to a dynamics calculation. So what I can do is I can set those by calling these things on the module. And as I mentioned earlier, if I want to call a module, I simply do it by calling modules and then the module name, in this case, mesosite. What I do when I tend to do these scripts is I create a variable, $mesosite, which points to modules mesosite. I do this because what I don't really want to have to do every time is type out modules mesosite geometry optimization run, or modules mesosite dynamics run, modules mesosite DPD run. What I want to do is just type $mesosite DPD run, or $mesosite dynamics run. And so by creating this pointer, I'm just saving myself effort in typing later on. So when I want to call something like this, I then call the global settings, then I call something called change settings, and change settings is a function that enables you to change settings on modules or tools or some of the other functionality in Material Studio. So I simply call change settings. I call my current force field, so I already know the name of my force field, and it has this slightly unusual forward slash, which is used only when calling a customized force field. Otherwise, you could generally do it by just using the name. And then you can see what I've done is I've just typed the values in, so the time here maps onto the time that I've got up here, and then the dissipation radius. The dissipation radius is also available here. There are other ways of doing these things as well. You can actually, in Material Script, save the state of a calculation. So if you set up a calculation and then click on Save Settings, you can then load those settings into the project. So if you don't want to hardwire all the settings within the module like this, within the script, you can use that way of doing things. However, I find it easier because what I want to do is make a script that I can just send to somebody else. Hence, I tend to put the state settings directly into the script rather than loading from state. The other thing that I've done here is I've used the write level. And the write level controls what documents are written out as the calculation progresses. So what I don't want to do is have hundreds and hundreds of live update charts or live update text documents being written as my calculation proceeds. So by changing it to silent, all I get is my trajectory and a report text documents at the end. So that set up the global settings for my calculation. Now I want to move on and do my initial dynamics. So what I'm going to do in this case is now I'm going to change the settings of the calculation in a slightly different way. So first of all, let's go down and look at the goal to do the dynamics run. And here you can see my results equals mesosite, and that's that mesosite that I defined earlier on as being modules mesosite. Then I call the task name DPD and then run. And that will be exactly the same as working through the user interface. I define the document that I'm going to run this on, and then I'm going to specify some settings, so the number of steps that I want to do in the dynamics and the trajectory frequency that I want in the dynamics. So how often is the frame written out? And by calling this, now I have a script that in those few lines that will now run a molecular dynamic, a DPD, dissipated particle dynamics for me on whatever document I pass into the structure. So that then means that I've changed those locally rather than globally. So if I then call dynamics again, it would just go to the default settings to run. The other thing about this, which was something that was introduced not in the first version, but introduced in the second version of Material Script, was the ability to call a results task. So what we have is when you run a calculation such as dynamics, what you're obviously going to do is you're going to create a new document, a trajectory document. And what I want to do is I want to know that I can point to that trajectory document when I do my next calculation, so that I can grab that trajectory document and use that as input. So the way we do this is we provide a results hash, and this hash, or this list here that I've got, this variable, will contain pointers to both my trajectory and my report, my text report. So I know then that if I now type $TRJ equals results trajectory, I'm then going to get that trajectory out of the calculation and be able to use that trajectory document. And in fact, the next stage that I do is I then change the name on that trajectory to something else so that I can identify it later on. But that's just an extra add. So I hope to have shown you so far how you can quite easily define settings globally for a calculation and then move on and run an individual calculation. The next step that I want to do is I want to change the lattice parameters. So I want to, having run my dynamics, I want to then increase the size of the cell and rerun the dynamics again so that I can look at the effects of that strain on the cell. However, you can't change the lattice parameters in a trajectory document that's been created in Material Studio, because that obviously invalidates the trajectory that you've created. If you play that, it would no longer actually have any meaning. So what I have to do then is very simply create a new XSD, a new structure document, and then copy the last frame out of the trajectory into the XSD, and then I can run my dynamics on that XSD. And again, this is something that if I was doing this through by hand, as it were, through the interface, I would have to go through and create all the new documents and then go through and select the atoms and then copy them into my new document. Whereas in Material Script, I can do this in a few lines. So the important lines here are these ones. So I simply create a new document with a specific name. I then set the current frame on the trajectory to being the end frame on the trajectory, so I know that I'm getting the last frame out of the trajectory. And then I copy from the current trajectory into my new document. Now, I'd like to introduce one final concept here, which I'm not going to go into a great deal, but I use these quite a lot. And you'll see at the top here of this script, it says sub copy last frame. So what I've done is I've created a subroutine to do this. And the reason I've done this is that I will use this same routine in several scripts. And in fact, I'll use it several times in the same script. And so creating a subroutine enables me to reuse that script without getting into problems. So why would I want to do that? Well, basically it enables me to reduce my code duplication. Now, this is a big thing when you work for a software house, and if you don't do this for a company that develops software, if I didn't do this, I would probably get shot by my own developers. However, it is really, really important, because it means that if I want to make a change, I only have to make that change in one place rather than 10 different places that I've used it. As I mentioned earlier, it enables you to reuse that code. I can just copy and paste it into a new script. It's also very easy to turn on and off bits of script. If I'm developing a script and I may be wanting to try several different ways of doing things, if I have just one line that calls a subroutine and I can hash that out, then that makes it much easier to turn on and off those bits. And then finally, it also enables you to create reusable Perl module libraries. And this is something that I'm not going to go into any detail with. There is a post on the forums in the tips and tricks section that I made recently on the value of doing this and how to go about doing this. Basically, in summary, from my perspective, it really is worth the effort to learn how to use a subroutine. And there's lots of different things out there, lots of different resources on Perl describing subroutines. and also many of the scripts that I've posted use subroutines within them. Okay, so I've been through and I've done my lattice stretch. I've then gone through and I've done my dynamics, which again I haven't detailed here because we've already talked about how to run dynamics. And then finally, what I want to do is read the stress out of each frame in the trajectory. And so I have a simple loop here, and what I do is I go through and I specify the frame number. So this goes from every frame in that trajectory. I know my frame number starting off is 1. It's always 1 because trajectories are 1 based. And then it'll go through to the last frame in the trajectory, which I've specified here using end frame. So what I do in each case is I initially set the trajectory current frame to the value of my counter, so I go through each frame. For each one, I grab the length in the A direction, which is specifically the length that I need. I then grab a pointer to the stresses, and you can see the stresses here, EIJ, and I'm grabbing the diagonal elements of the stress matrix in this case. And then I simply have a bit of math, surface tension, which calculates the surface tension from the different stresses and the lengths that I've defined. And again, I can then just print that surface tension out into a text file. In the actual script that I've used, I do a little bit more than that, and I print it out into a study table and all sorts of different things, calculate some statistics on it as well, but I didn't want to go into that much detail here. So once I've done all of those things, what does this enable me to do? Well, this enables me to strain the membrane, equilibrate with molecular dynamics, or DPD dynamics in this place, and calculate the surface tension. And in this application, what I end up with is I increase the amount of lipid in the system, then I end up with an increased surface area that I can stretch my calculation to before it begins to break. As I've written out that, calculated that surface tension, I can also plot the surface tension, and you can see here that this is where it breaks for this particular system, and you can see the surface tension increasing as the calculation progresses. Each of these dips or in the system are where it goes to a new strain. So after I've just proposed a strain, the system relaxes very quickly down to give me a stress again. Okay, so that kind of wraps up what I wanted to talk about in terms of the material script API, and I hope I've shown you how you can use it to generate, to automate certain workflows. Certainly all of those calculations would have taken me a long time to do individually if I'd had to sit there and wait for one to finish before I started the next one. Whereas using the material script API, I managed to string those together, and I can just run them overnight and come in and get the results the next morning. So in terms of some resources to help you generate material scripts, we have extensive online help. The section of the help is called Scripting in Material Studio, and this goes through a whole range of things such as running the scripts and dialogues in scripting, and some of those things that I talked about earlier in terms of the workflow for writing a script. And then also it has all the different properties in the Property Explorer, labeled in and all the different classes, so molecules or hydrogen bonds, all of the different sort of properties on there are also available. The different functions, the different commands, calculate close contacts, calculate Conley surfaces, or renaming or deleting, all of those are detailed in there as well. And then the different tools and modules that are available from the Material Script API. So that's really kind of the first place to start. And if you put your cursor into a script command, if you type it in and then press F1, then that will automatically take you to the relevant pages or give you a selection of pages to choose from. So if you just type in Foresight and press F1, then you will go to all the Foresight online help. So it's pretty interactive there. Also, there are lots and lots of example script fragments already available in the online help. So really, really a very useful place to go. Otherwise, the Axaris community forums on axaris.org. There's a massive material script library there. I think there's upwards of 50 scripts now available, written by a variety of people and me, and they do a variety of different tasks. So lots of things that you can go and use in there. Then there are also example scripts. So this is a little known area, but if you go to the examples area in your Material Studio installation, there are several example scripts in there which are well commented and again designed to give you a feel for how to write a script and what sort of things can be automated. And then finally on the Perl front, again there are many different websites dealing with Perl. And initially you probably won't have to deal with that much Perl anyway, but as you get into in depth and things, you may want to start using arrays or using different types of data structures to store information. I've listed one here on the TISAG website, which is one that I go back to again and again whenever I forget precisely what I'm supposed to type. But again, there are many others out there. So thank you for your attention throughout this webinar, and I'd just like to say what's next in terms of upcoming webinars. The next one on May the 19th is Materials Modeling in Pharmaceutical Development. And then we've got one on May the 20th, which is a Pipeline Pilot webinar series, which kicks off with what's new in Pipeline Pilot 8.0. We're also available at upcoming events. So Nanotech 2010, which is running from June the 22nd to the 23rd at Anaheim in California, will be there, and you can obviously always visit our events web pages. So with that, I will wrap up and say thank you for your attention and for your time today, and I'll begin to take any questions that have been posted. Okay, so one question was, why would I select the last frame of the dynamics? That's not the average structure of the system. So when I'm doing my stretch in my system, I just need something that represents the dynamics, the next frames to take. So basically, I take the last frame just because that's the easiest one. I know that's probably reasonably well equilibrated, but I'm going to stretch that anyway. In reality, it probably doesn't make that much difference, but you do want to take something that has been semi-equilibrated. You don't want to take something that's right back to the start, because then you would be stretching a much greater distance and you would be deforming your bonds far more than would be expected. So I picked the last frame in the dynamics run because it's the one that should be available. It's the one that represents the best equilibration at the time. So what was the website that was mentioned where the example scripts are located? So I'll just go back to that. The example scripts are available on axaris.org. If you go into axaris.org, that's basically a library view. You can click on the scripts, and then you would have to register on the Axaris community forum underneath the hood. And once you get into there, that's where all the scripts are stored. So I would strongly recommend you register on the Axaris community forum, and that will then enable you to get these things. Another question on, is there a generic tutorial that can lead me through this? Yes, there is in the Material Studio online help. If you go to tutorials, there is a scripting tutorial, and that one details how to look at calculation of the interaction energy between two surfaces. So it deals with modules, and it deals with some basic loops as well, and that should give you some idea of how to start. But again, the best way to do this, I would recommend you take a look at the tutorial, and then you take a look at at the website, theexaros.org, or the examples folders in the Material Studio installation. Pick something that's close to what you want and then start to manipulate it. That's generally the best way of doing these things. Obviously, if you do have specific questions, you can post them into the Material Studio forums as well. There is a general script forum where people do post questions that get answered on specific issues. Okay, so with that, I'd like to wrap up this webinar for now. I don't see any other questions coming in. If you do have questions, you can contact me via the forums. I'm on there as Stephan Todd _Axalis user, and you'll see me.
Stephan?
Yeah, sure.
Stephan, yeah, I actually sent the message. I don't know why you didn't see it. I just wanted to ask if you could comment on the relationship and future plans of scripting versus pipeline piloting.
Yeah, sure, I can do that. Basically, the plans are that we are developing the Material Studio collection, which is a collection of modules that's available in Pipeline Pilot. And really what I see is that Pipeline Pilot presents us with a graphical way of generating workflows. This will be available hopefully reasonably shortly, although I can't commit to a date yet when that will be available. And what we do is we actually use Material Script to generate a lot of the components internally. And the fact the Material Studio collection has a direct Material Script component, which enables you to run Material Script components within Pipeline Pilot. So there's a very close link between Material Script and the Material Studio collection. And there's a lot of things that you can do just with with a Material Studio collection. But again, if you want to get into advanced things, you'll need to use a little bit of Material Script in there. However, it's certainly a very different and some would say an easier way of generating workflows with use Material Studio components. Does that answer your question?
Yeah, so then basically they will coexist.
Sorry?
So basically they will coexist.
But they will indeed, yes.
Okay. Thank you.
Okay, no problem. So there's a question about making up a force field on the fly for mesosite. Now, that's not actually, so the question is, how do I generate the force field on the fly? Well, actually, the force field that's generated in that example is one that's generated from a study table of existing force field parameters. So we are working on some scripts that generate force fields on the fly for mesoscale systems, but we are not ready to distribute those yet. So the force field, the script that you're looking at is one that works by taking existing parameters from a study table and then just creating a script. And it was a simple example to show how you can create and manipulate force fields from within the script. Okay. Any more questions? If not, then again, I'd just like to thank you for your time today. And if you do have any other questions on Material Script, I can be reached in the forums, or generally, it's a good way to reach the community of people who are dealing with and working with Material Script in Material Studio. So thank you for your time, and good luck with your scripting. Goodbye.